Let's consider this application dealing with Ohm's Law. So we have a typical car battery, 12 volts. Fully charged, it actually registers 12.6 volts. 12 volts are what's actually utilized by the car, and the other 0.6 volts is typically what is transferred or lost to internal resistance of the battery. And we're going to analyze both parts of that voltage. According to popular mechanics, a typical car starter, which is the predominant thing that your battery is used for, requires 250 amps for about a half a second. So then we know several different things. 12 volts, and that's what is established across the starter. The remaining 0.6 volts, that is related to the internal resistance of the battery. We also know 250 amps. So a current I of 250 amps for a time period of a half a second is what's needed for the starter. So let's consider what we want to calculate. A, calculate the resistance of the starter. Well, applying Ohm's law, V is equal to I times R, and we want to apply this to the starter. So we need the volts that are established across the starter, 12 volts, the current, 250 amps, and then R, our resistance, is unknown. So when we do the division there, we get a resistance of 0.048 ohms as an average resistance for that starter. In part B, calculate the internal resistance of the battery. Well, now we're still applying Ohm's law, V equals I times R. I'm going to write the internal resistance of a battery as a lowercase r. That's relatively standard to do that. So we're dealing with the internal resistance. So then our numbers need to relate to that internal resistance or that battery. So then our voltage is 0.6 volts. I, it's still the same current because the current flows through the whole circuit. 250 amps. And then we're solving down for the resistance, the internal resistance of the battery. So dividing, we get 0.0024 ohms. And that's internal resistance for that battery. Part C, calculate the amount of charge transferred when the car is started. Amount of charge in part C, that's a delta Q, which means we're going to have to pull our current equation. I is equal to delta Q over delta T. So our current is the 250 amps. Our time period is the 0.5 seconds. So 250 amps is equal to delta Q over 0.5 seconds. So then we solve down for an amount of charge of 125 coulombs that are transferred in the starting of that car. Ponder physics.